Thanks for joining us for the interview portion of the Data Speaks competition created in partnership with RFG 2018 and Sequent. I'm Nicole Doucette, a science communication specialist from Sequent, and I'm joined today by Zeinab from the University of New Brunswick. Welcome.
Thank you very much. Thanks for having me.
Of course. Okay, Zeinab, so your original abstract title was Apatite Chemical Composition from Acadian-Related Granitoids of New Brunswick, Canada, Implication for Petrogenesis and Metallogenesis.
Yeah, I know, that's a mouthful. So basically, what that all means, it actually tells you how you can save big money, big bucks, using mineral chemistry in mineral exploration industry.
Great. So what question are you trying to answer?
So basically what I'm dealing with is that the humans have been trying to correctly identify the location of a mine site and most importantly, a potential mine site that is profitable. But even though they've been trying so hard, they haven't been successful doing so. And they have come up with so many different ideas, but nothing has actually been worked so far. So they are still trying. And then because the technology is advancing really, really fast now, so many new ideas have come to the light. And one of this idea have been it's been proposed 1960s, that decade, but no advancement in it. So I took the idea and I started playing around with it using the new technology that we have today, trying to use the mineral chemistry to kind of go back and study the parent magma. So what we usually do is that we go through the mineral chemistry and some of these minerals that could actually reflect the physiochemical changes in the parent magma, and we kind of study the magma using the mineral.
Cool. So what concept does someone need to know then to understand your research?
So you need to understand two different conceptions to understand my work. So basically, to have a rock, you need two different minerals. And the mineral that I'm interested in is one of the minerals that could actually record the evolution history of its parent. In case of my study is apatite, which is a phosphate mineral. And if you go in detail of the chemistry of the mineral, you can study physiochemical changes like pressure, temperature, oxygen free gas that is, and all the important stuff that you need to know to understand if a rock could be related to a mineralization or not. And then the other concept you need to know is that I'm using granites. So granites are the light-colored rocks that they crystallize from the magma on the the outer part of the planet that geologists call it crust, and it's really common. And granites are related to so many different styles of mineralization. So if we use apatite, which is a common mineral in that really common rock, we are dealing with a really good deal. So we basically look through the whole thing and we're trying to figure out where we can find a mine.
Great. So what role does data play in your research?
It's actually really important. It is the base. So what I do, I go out, I collect sample, I bring them in, and then I have to analyze them with some, at least 3 different high-tech technology analyzing system. Then I go back to my lab, look at the data. So it basically gives you the ppm level of elements that you have in that specific mineral. You sit down, you go through the data, and you correct it because not everything that we collect is correct. And then when I'm done correcting the data, I upload my data to the statistical softwares, and then I'll start plotting them and see if I can see any anomaly in the data. And I also have collected data from elsewhere, like big mines and stuff, and then I go through them. So what I do, I have samples from the mineralized granites and the barren samples, and then I compare the geochemistry to see if I can basically see any major geochemical difference between the two groups. And my study showed, yes, we can use apatite. So I show you.
And so why is it important for you to share your data and your research?
So it is important because granite is a really common rock within the crust, and it's basically all over the place. And then apatite is also a common mineral within that. So what we do, if we can, I prove the concept in New Brunswick, Canada. So if we get data from all over the world and then we compare them, maybe we could find a same path. So it's kind of like I propose something, the rest of the people could apply this to their own data, and if that actually helps to prove the concept, we can use it as a mineral exploration tool and save a lot of money. Instead of drilling and spending so much money, you can take some samples, look at the chemistry of the mineral, and solve the issue. So.
Great.
save money.
Yeah, always important.
Yes.
Well, thanks for joining us today, Zeinab.
Well, thanks for having me.
Of course. Once again, this is the Data Speaks competition at RFG 2018, created in partnership with Sequent. You can watch the videos on YouTube or Twitter, #CDataSpeak.